Okay, so now the next topic is pseudo convex function. So in pseudo convex function, here we take function, it's a differentiable function. Okay, so here we take a differentiable function like so if we assume that a function, suppose a function f which is defined on some open set defined on some open set for C in Rm, the differentiable function, the differentiable on convex set C. So the function f is then said to be pseudo convex function. Okay, this is a simple definition of pseudo convex function. So if for each x1 and x2 which belongs to this convex set C, and so equivalently, if for each x1, x2 belongs to set C, and fx2 is less than fx1, this implies this gradient of fx1 transpose x2 minus x1, this is less than 0. Okay. So either this or this, if this condition is satisfied, then you say that this function is pseudo-convex function. Okay, and any function is said to be strictly pseudo-convex function. So the function f is said to be strictly convex function, strictly pseudo-convex function if for each x1, x2 that is belonging to that set C, and of course these two are distinct one. This means these two are not equal. Okay, and this condition is satisfies gradient of fx1 transpose x2 minus x1. This is greater or equals to 0, implies fx2 is greater than fx1. Okay, or in this way, or equivalently, you say if for each x1, x2 belongs to C, and x1 is not equals to x2. This fx2 is lesser equals to fx1 implies that this gradient of fx1 transpose x2 minus x1, this is less than 0. Okay, so this means this part. If this condition holds, then this implies this thing. Okay, and the function is said to be pseudo concave. So here the remark is the function f is said to be pseudo concave or strictly pseudo concave if this minus of f is pseudo-convex. Pseudo-convex, or for strictly pseudo-concave, so this is strictly pseudo-convex. Convex. Okay, so here one more remark, that is pseudo-convex and pseudo-concave. If any function have both property, okay, then that type of function is said to be pseudo-linear. Okay, so pseudo-convex and pseudo-concave, if any function have both property, then this is belongs to this pseudo-linear function. This is basically pseudo-linear. Okay, so this is a simple definition of this problem. So what is the pseudo function? So on next page, we define take a function which is a pseudo function but not convex function. This means if any function which is a pseudo convex, okay, so this need not be, this function is your convex function. If any function which is convex, then of course pseudo convex function. But pseudo convex function जरूरी नहीं कि वो आपका convex function हो. Okay, so take an example, and you take any odd order of any function, okay, and that is your simple example of your that function is not convex, but that satisfies your pseudo convex. So next page, next page page, a pseudo function convex. Okay, so if you take example, and that function is suppose x plus x cube, we take this function. So this function is to take this function is convex or not. This function is convex or not. So we check that function is not convex. Okay, so here if we take any 2 points, suppose x1 is less or equals to x2, so this implies if we take x1 less than है, then x1 cube, okay, is also less than of x2 cube. Okay, so thus you have to find this gradient of fx1 transpose and x2 minus x1. You find this value. So what is the gradient of fx1? So what is the value of fx1? Fx1 is x1 plus 3x1 cube, or x1 cube. So if you differentiate this gradient of this, x1 has differentiation 1 plus, and this is x cube is 3x square, so 3x1 square, so 3x1 square, x2 minus x1. This is x2 minus x1. So this is plus 1, and this is square sign. This is also greater than 0, and this is greater than 0. So this sum is also greater than 0. X2 is of course x2 minus x1 is greater or equal to 0. So this product is greater or equal to 0. Okay. So this implies we say that so, this function or we calculate another value, that is what is the value of fx2 minus fx1. Okay, so we take fx2 minus fx1. So fx2 minus fx1 means this is x2 minus x1 and x2 cube minus x1 cube. Okay, because x1 has x1 plus x1 cube and the x2 plus x2 cube. So if you're subtracting these two, this comes different. Okay, so here x2 minus x1 is greater than 0. Okay, and x2 cube minus x1 cube, of course, this is greater than 0. So this is greater than 0, this is greater than 0. The sum of these two is also greater than 0. Okay, so this implies you find here this x2 is greater or equal to fx1. Okay, this fx2 is greater or equal to fx1, and here you find this thing. If this is greater or equal to 0, implies that fx2 is greater or equal to 0. So you can find here this fx is pseudo convex function. Okay, so this is your pseudo convex function. So this is a simple example, and you check that this is a convex law. So you check that this portion, this function is convex or not. Okay. So if a function is defined on an open convex set, and is differentiable when we have the following relation. We have the relations, and that relations any function which is defined on convex set. So if any function which is you check that if that function is strictly convex function. Okay. Any function which is strictly convex function, so this implies that that function must be convex on same domain. Any function which is strictly convex, this implies that convex. But if any function is convex, it will not be strictly convex. So converse is not true. Some examples are there where some functions are convex and also strictly convex function. But here there are every function which is strictly convex, then that function is convex. And every convex function is by that function is also has property that is pseudo convex function. That function is pseudo convex. Okay, but ये जरूरी नहीं कि pseudo convex function है तो convex function होगा. Okay, converse is not true. And if any function which is pseudo-convex function, okay, so then this function implies that if any convex function implies that this is also explicitly quasi-convex. Okay. So this is also explicitly quasi-convex होगा और explicitly quasi-convex है तो वो आपका quasi-convex भी होगा quasi-convex. ओके तो ये सारी चीजें हैं कि if any function which is strictly convex then वो convex होगा, convex है तो pseudo convex होगा, pseudo convex है तो explicitly quasi convex होगा, quasi convex है तो quasi convex होगा, but converse is not true. Okay, and if any function which is suppose not differentiable, if we take this type, so in that case this condition doesn't hold. Okay, if any function which is not differentiable, then this pseudo convexity हटा देंगे आप, this to be convex, then convex, then strictly quasi-convex, and then quasi-convex. If this function is differentiable, then this property holds. Okay, so अगर ये कंडीशन है तो ये कंडीशन आपकी फुलफिल होगी, अदरवाइज नॉट डिफरेंशिएबल है तो ये चीज़ आप रिमूव करेंगे. So now if we try to give some remark here, every convex function basically
सर नॉट डिफरेंशिएबल का क्या कंडीशन बताए और एक बार बता दीजिए ना.
if this function is not differentiable है तो pseudo convex प्रॉपर्टी नहीं होगी ना, बिकॉज pseudo convex फंक्शन तो वहाँ अप्लाई है जो फंक्शन मेरे क्या डिफरेंशिएबल हो. ओके, तो जो फंक्शन हमारा डिफरेंशिएबल ही नहीं है तो उस केस में हमारे पास ये जो सीक्वेंस है वो इस फॉर्म में होगी. स्ट्रिक्टली कॉन्वेक्स फंक्शन होगा एंड वो कॉन्वेक्स फंक्शन मेरा एक्सप्लिसिटली क्वासी कॉन्वेक्स होगा और एक्सप्लिसिटली क्वासी कॉन्वेक्स हमारा क्वासी कॉन्वेक्स होगा इफ द फंक्शन इज नॉट डिफरेंशिएबल. ओके, तो इफ नॉट डिफरेंशिएबल देन स्यूडो कॉन्वेक्सिटी उसमें प्रॉपर्टी होल्ड ही नहीं करेगी, इसलिए वो चीज नहीं होगी. अगर वो फंक्शन मेरा डिफरेंशिएबल है देन स्यूडो कॉन्वेक्सिटी आएगी. और ओके, so every convex function is quasi-convex. Okay, a concave function can be quasi-convex function. Okay, so and third one, any monotonic function is both quasi-convex and quasi-concave. Okay, so these are the some results, and here you take the example of this. Any concave function is this thing means if you take any function which is log x. Okay, so log x is if you take log x function, fx is log x. So this function is concave. This function is concave, and also this is quasi-convex function, and this is also quasi-convex function. Okay, so here we give some example. Okay, so if we take some graph, so on next page, Suppose this is your axis. If we take this type of function, okay. So this function is basically this function is non-convex. Okay, and if we have to define any convex function, so if we take this function is convex because if we take any 2 point on this, okay, function, the straight line is always above that function. But here you take here, if we take these 2 points, okay, this portion, this is convex, but here this line is below from this curve, so this is not convex and not concave both. Okay. So what type of concave function? So concave function, if looking like that, if we take something like that function, so this function is concave because if we take any 2 points, that line is always below from this curve. Okay, that is the convex function. So you take this type of function. This is a convex function. Okay, so if anyone are interested to find what is the if you take this type of function, if you take this type of function. Okay, so this function is quasi convex, and also this is कॉनकेव. ये आपकी कॉनकेव भी है और क्वासी कॉन्वेक्स भी है. क्यों? क्योंकि फंक्शन की जो वैल्यू है दैट इज ऑलवेज द मैक्सिमम एंड मिनिमम वैल्यू ऑफ okay this function. Okay, so this value of this function between these 2 points is always less than the maximum of these two fx1 and fx2. Okay, that's why this is your quasi convex function and this is also concave function. और अगर आपको क्वासी कॉनकेव बनानी हो तो आप कुछ इस तरह से भी बना सकते हो जो कि आपकी जो कॉन्वेक्स फंक्शन. और यहाँ पर भी वही चीज होगी बिकॉज माइनस ऑफ दैट इज योर क्वासी कॉन्वेक्स फंक्शन, सो दैट्स व्हाई दिस इज योर क्वासी कॉनकेव फंक्शन व्हिच इज क्वासी concave function. Okay, so there are some examples of different type of curves. Okay, so any student who's trying to make this type of curve, suppose we make this type of curve. So this is quasi convex, this is quasi concave, but not concave. Okay, but not concave. And if any curve like this, suppose step like, okay, so this is quasi convex and quasi concave both. This type of function is quasi convex and quasi concave, both type of function. Okay, so there are some more examples, which is if we plot this type of curve, this type of curve, so this is not convex and not concave. Okay, if we take in single line this is convex and concave both. Okay, so if we draw this type of function, okay, this is your quasi convex. So there are examples of the curves. Okay, so now we go through on the next topic, that is the conjugate function. So what is the conjugate function and what is the properties of that? Okay. So next page.
एक मिनट रुक जाइए.
Okay.
Yes sir, हो गया.
Okay. So next page. Next one is conjugate function. So let any function f that is from Rn to R, the function we define conjugate function that is f star, this conjugate function. This is mapping from Rn to R, and this is defined as this f star of y that equals to supremum of when x belongs to domain of f, and this is y transpose because y is the element of this Rn. So y transpose x, and x is also element of this Rn. So y transpose x minus this function fx is called conjugate of f is called conjugate of f, and the domain of the conjugate function consists of this y, that is your domain conjugate function, y belongs to Rn, for which the supremum is finite. If the supremum is finite. So that is, this means for which the difference that is y transpose x minus fx is bounded above the domain of f. Okay, so this is a definition of the conjugate function. Okay, so here we take some example and try to find what is the conjugate function and what are the domain of that function. Okay, so here we take some example. So any function, suppose R to R, and first of all we take a simple function that is linear, or you say affine function. So let fx, that is ax plus b, that is a linear function, or you say affine function. Affine function. Okay, so as a function of x, you have to find as a function of x, you have to find this y transpose, and because here this is from R to R, so y is also one dimension. So this is y of x because y transpose. This means one dimension, so this is y into x minus of fx. Okay, this value is yx minus what is the value of fx? Fx is ax minus b, and this is to check that this yx minus ax minus b, this is bounded. This is bounded if and only if and only if this when this y becomes a, so y equals to a, because if we differentiate this term, if we're differentiating this yx minus ax, this term, it becomes with respect to x, we get y minus a, and that equals to 0 because as this derivative with respect to x equals to 0, so y equals to a. Okay, so you find y equals to a. If and only if this y equals to a. So in this case, it is constant. It is constant, and therefore the domain of the conjugate function, that conjugate function is f star, is in this case you get this is y equals to a. Okay. So what is the domain of this conjugate function? This is a y star. Y star is, we take this value and this, when we take x equals to what value of domain, which when this value supremum. Supremum means for supremum, maximum, minimum, we take the first derivative equals to 0 and taking the value of that. So here you get this y equals to a. So here it's only one value, and that is the singleton set a. So is the singleton a. Okay, so only this thing. And what is the value of this function f star of y and f star of domain of only a, f star a? So if you putting here, what is the value of this f star a? We putting y equals to a here, ax and ax are cancelled out. This is simply minus b. So this is your value of conjugate function. Okay. Similarly, if we take an example, and if we take fx with a logarithmic function, suppose we take minus of log x. Okay, and what is the domain of this f? Domain of this f is r plus plus, because this x is a positive one and also
सर
non-zero. Okay.
सर ये सिंगलटन ए लिखा है कि एक्स लिखा हुआ है?
So let us a, only a. This is a. Okay. So here fx is minus log x, and we take x equals to not zero, okay, and non-negative, because log of minus infinity, log of minus terms are not defined, and log of zero is also not defined. So that's why we take only the domain of f is domain of f all x which is greater than zero here. Okay, this means we take x is greater than zero. Okay. So here this function, the function, we have to find conjugate function के लिए हम क्या करेंगे? Y into x, so y into x minus of fx, so minus of fx, so this equals to yx minus fx to minus and plus log x. Okay, so you have this thing. So this is basically unbounded. This function is unbounded ever if y is greater or equal to 0, because these two terms are okay, this plus and this thing, x is those term which is positive one, so log of this is always positive. Okay, and here if y is your free domain which belongs to your r. Okay, and you have to find out what is the domain of that y. If we take y is positive 1 and x is also positive, so this product is positive 1, and here log of that x is also positive 1. So if we take any value of y which is greater than 0 and x has a greater than 0 value, so this value is very large plus this value is very large, so this value is unbounded ever. Okay, so if y is greater or equals to 0, when equals to be 0 हो जाए, उस केस में भी log of x, ये भी आपको x of very large लेंगे तो log of that value is also very large. Okay, so this is unbounded. Okay, so and this is reaches to maximum one. So ये आपका maximum कहाँ पे जा सकता है? Okay, so and reaches its maximum के लिए आप क्या करते हैं? आप उस फंक्शन की डेरिवेटिव निकालेंगे. तो दिस फंक्शन की जो फर्स्ट ऑर्डर डेरिवेटिव होगी, this function first order derivative with respect to x, if you differentiate this function, okay, so you get y plus 1 by x that equals to 0, because if you differentiate this function with respect to x, this is y plus log x 1 by x equals to 0. So this implies you get x equals to minus 1 by y. So this reaches to the maximum at x equals to minus 1 by y. Okay, so therefore, the domain of this conjugate function, is very simple. This is simply all y which is less than 0, because when y is greater or equals to 0, this is unbounded area. Okay, and you say this is a minus of r plus plus. Okay, and what are the value of this conjugate function f star of y, this equals to, here we putting simply the value of this f star y. F star y is, here we put y, okay, and in y equals to 1 minus 1 by x, y equals to uh, oh, y equals to x equals to 1 minus 1 by y into x plus x, okay, x y m. This equals to yx. So we have to put in the value of x. When we maximum is x equals to minus 1 by y. This is y into x equals to minus 1 by y, minus 1 by y, plus log of x is minus 1 by y. So here this term is cancelled out. This is a minus 1. And here log of this minus log of this. So this becomes minus log of minus y and minus 1. And here of course y is less than 0. So this is your conjugate function, and that conjugate function is minus of log minus y minus 1 when y is less than 1, because this domain is y is less than 1. Okay. So now we take some more example on this conjugate function. Okay, तो एक हम exponential function ले लें और हम product of function लेकर देखें. Try to find the conjugate function. So next page. So if you suppose an exponential function, you take this e to the power x. Okay. So you have to find the value of the function which is y transpose x. Y transpose x means yx minus fx. Okay, so this means y of x minus fx which is e to the power x. Okay, so here you take this function, and this function is basically unbounded. This is unbounded if y is less than 0. If y is less than 0, then this is negative, and exponential of this is negative. So negative. Okay, this means this is unbounded below if y is less than 0. Okay. For if we take y is greater than 0, so this xy minus e to the power x, this reaches to the maximum. This reaches to maximum. This reaches to maximum. Here x is belongs to a plus. Okay. So this reaches to the maximum when maximum कब जाएगा, जबकि आप इस फंक्शन को जरा डिफरेंशिएट कर रहे हैं विद रिस्पेक्ट टू x. अगर डिफरेंशिएट करते हैं, दिस इज y minus e to the power x that equals to 0. So here, what is the value of y? Y is equal to power x. What is x? So x is log y. Okay, this is reaches to the maximum when x equals to log y. Okay, so this is reaches to maximum at x equals to log y. So we have conjugate function, that is f star of y is equals to simply what is the value of this? F star y is yx minus, this is yx minus e to the power x, and here we putting here the value of x here, so this becomes y, and x equals to log of y minus e to the power log of y, so this equals to y log y minus y. Okay, so this is the value when, okay, and for if we take quickly one more example, which is fx is suppose x log x, and domain of f is suppose belongs to r plus. Okay, and also this is given f0 is 0. This is also defined because if we take 0 here, so this is log 0 is infinity and 0 into infinity in different form, so that's why we define here f0 is 0. Okay, so the function is yx minus fx is equals to yx minus x log x. This function is bounded ever on this r plus for all y. Okay, so if we take this thing, so this means you say that the domain of f is star is real R. Okay, and it allows it attains the maximum. It attains its maximum at if we try to differentiate this function x log x. If we differentiate this to x, this is y minus first function differentiation of second, then log x that equals to 0. So that's why y equals to y minus 1 minus log x that equals to 0. So y minus 1 equals to log x. What is the x is e to the power y minus 1. So tends at x equals to e to the power y minus 1. And what is the value of this function? This function is y star. So you have to simply putting here y x minus this. So this is y. What is the value of x is? X is the value e to the power y minus 1 minus x is e to the power y minus 1 log of e to the power y minus 1. Okay, so you have to calculate this term. So this term is e to the power y minus 1 into y minus, this is it's log of e to the power y minus 1, so this becomes y minus 1 and exponential of y minus 1. So exponential of y cancel out, so this becomes e to the power y minus 1. So this is the conjugate function for this x log x. Okay, so similarly you can find any conjugate function for given function. Okay, so on next page we define what is the double conjugate. Next page. So let f, that function is defined from Rn to R, the function, and if we define conjugate function, that is f of star. Okay, this is star be its conjugate, and consider the double conjugate. Double conjugate function, that is f of star star. Then this f of star star of x is always less or equals to your original function fx for all x belongs to Rn. And this f of star star double conjugate function is equals to fx for all x belongs to Rn, if and only if both are same, if and only if the function is the function f is convex. Okay, f is convex. Okay, so this is said to be closed and proper. This is, note that this is closed and proper function. Proper means fx is finite one, and closed means f is semi-continuous function. Okay. So okay. So this is a definition of conjugate function, and there is also some definition which is what is a log concave and log concave function. So उसे हम define कर लेते हैं. तो आज से डिफाइन definition ही करते हैं, और न्यूमेरिकल से नेक्स्ट टाइम पे करेंगे. What is log concave and log convex functions. Okay. So function which is from R into R is logarithmic technically concave, or we say log concave if your function f is greater than 0, your fx is greater than 0 for all x, this belongs to domain of f, and log f is concave. Okay. And function that is from Rn to R is log convex if the function is greater than 0 for all x which belongs to domain of f, and this log f is convex. Okay, so that type of function is known as log convex function. Okay, so if any function, if this f is, I will say that a function f is a function f that is R into R with convex domain.
सर
Yes, yes.
सर ये लॉग कॉनकेव और लॉग कॉन्वेक्स की कंडीशन दोनों सेम ही रहेंगी क्या?
नहीं, यहाँ पे log f is concave, here log f is convex.
ओके सर.
There is difference between these two. If f is R to R with convex domain, and the function is positive for all x which belongs to domain of f, is log concave. This is log concave if and only if and only if for all xy, for all x and y which belongs to domain of f, and you take any theta, okay, which is lies between 0 and 1, then we have the condition.
हेलो सर.
हाँ बताएं.
हेलो
हाँ बोले.
सर लॉग कॉन्वेक्स और क्या कहते हैं लॉग कॉनकेव में दोनों में fx इज ग्रेटर देन 0 पे होगा कंडीशन में.
हाँ basically both is greater than 0, but subject to condition is here log function is concave and log function f is convex. Okay, so this is the main difference between these two. If any function which is greater than 0 for all x which is belonging to that domain, okay, and if log of that function is convex, then we say log convex function. If log f is concave, we say log concave function. Okay, no difference between here ये पॉसिबिलिटी मत कर लीजिए. कोई भी फंक्शन ऐसा हो जो डोमेन पे ग्रेटर देन 0 हो और log f को अगर हम देखें, अगर वो कॉन्वेक्स है तो हम कहेंगे log कॉन्वेक्स फंक्शन, अगर वो कॉन्केव है तो हम कहेंगे log कॉन्केव फंक्शन. क्लियर? या फिर आप एक दूसरी तरह से भी कह सकते हैं कि किसी भी फंक्शन जो कि मेरा डोमेन पे डिफाइंड हो, वो डोमेन आपका कॉन्वेक्स सेट हो और मेरा फंक्शन जो है वो हमेशा ग्रेटर देन 0 हो, उस फंक्शन को हम log concave कब कहेंगे? If and only if we have this condition holds, and that condition is f of theta x plus 1 minus theta of y. This is greater or equals to fx to the power theta into fy to the power 1 minus theta. Okay, this is to the power theta and this 1 minus theta. Okay, so this is said to be log concave function. Okay, तो ये आपके डेफिनेशन है. कुछ एग्जांपल्स हम यहाँ नोट कर लेते हैं. यहाँ स्पेस है, तो अगर आप कुछ एग्जांपल देखना चाहें इन फंक्शंस का एग्जांपल्स, ओके, तो इसके लिए हम एक ओके तो ये फंक्शन हम लिख सकते हैं अफाइन फंक्शन. तो इफ fx is affine means a transpose x plus b, and this function is affine function. So this affine function is, आप चेक करिएगा, that is log of concave function. This is not concave है on the domain. That domain is x such that a transpose x plus b is greater than 0. Okay, so this means in one half space we check that this is log concave or not. Second example आपके लिए देते हैं कि if we take fx is suppose any a to the power x type of function ले लें, x to the power a type function, कोई polynomial ले लें x to the power a polynomial, okay, on this r plus plus. So this type of function polynomial is log convex subject to the condition where a is less or equals to 0, and this function is log concave. ये कॉन्केव हो जाएगा जब आपका a जो है वो हमारा ग्रेटर और इक्वल्स टू 0 होगा. ओके, और बिकॉज x इक्वल्स टू 0 पे क्या होगा? 0 पे दैट इज 1, तो कांस्टेंट फंक्शन होगा. तो कांस्टेंट फंक्शन इज लॉग कॉन्वेक्स और कॉन्केव दोनों होते हैं. ओके, तो कांस्टेंट फंक्शन, इसलिए आप ये देखेंगे तो इक्वालिटी साइन हमने यहाँ पर भी लगा रखी है और यहाँ पर लगा रखी है 0 पे. तो इफ a इज ग्रेटर देन 0, दिस इज लॉग कॉन्केव. a to the power means 1 upon something, x to the power 3, x to the power 4, 1 upon something. This is log convex. And third one, if we take an exponential function, this is linear, this is polynomial, and this is exponential, e to the power something power of ax. So this type of function is log convex and log concave both. Okay, तो ये log convex भी है, log कॉन्केव भी है. और एक एग्जांपल और ले सकते हैं, दैट इज योर गामा फंक्शन. दैट इज गामा फंक्शन. दैट गामा फंक्शन इज डिफाइंड बाय गामा ऑफ x, दैट इज 0 to infinity e to the power minus t e to the power x minus 1 dx. Okay, गामा फंक्शन, you know that in मल्टीवैल्यू कैलकुलस आपने पढ़ा होगा. ओके, रियल एनालिसिस में दिस इज गामा फंक्शन. दिस गामा फंक्शन इज लॉग कॉन्वेक्स. ओके, दिस इज लॉग कॉन्वेक्स फॉर x is greater or equals to 1. So these are some examples of log concave and log concave functions. Okay, so इसको अगर चेक करें और फिर नेक्स्ट टर्न पे हम और आगे दूसरी चीज लेके चलेंगे. और बहुत ज़्यादा थियरी हो गई है, कुछ न्यूमेरिकल्स पे चलेंगे और कुछ एक आध दो थ्योरम्स और है, तो उसके बाद तो पूरी न्यूमेरिकल ही है आपके कोर्स में. कुछ कॉन्वेक्स एनालिसिस में थोड़ा सा एक आध थ्योरम्स और हैं जो डिफरेंशिएबिलिटी फंक्शन की है उन पे, उसके बाद की सारे के सारे न्यूमेरिकल ही है। ओके ठीक है, तो आज के लिए इतना ही करते हैं, नेक्स्ट टर्म पे फिर मिलेंगे। ओके हाँ बोले बताएं।
ये जो आपने पॉइंट लिखा है ये कॉनकेव फंक्शन, ये जो थर्ड पॉइंट लिखा है f(x) = e⁴ax, इसके नीचे वाली लाइन एक बार सर पढ़ दीजिए, क्या लिखा है आपने?
फोर्थ एग्जांपल दिया है गामा फंक्शन, GAMMA गामा फंक्शन, एंड दैट गामा फंक्शन इज डिनोटेड बाय कैपिटल गामा, जो नोटेशन है दैट गामा x इज डिफाइंड एज इंटीग्रल 0 to infinity e⁻t into t⁻x-1 dx. This is the definition of gamma x. Okay, and this gamma function is log convex for x is greater or equals to 1. Yeah.
Okay sir, thank you.
Thank you, sir.
Okay, thank you to all.
Thank you, sir.
Thank you to all.